Look at this. For the given data, mark of a student is given. How many students got that mark? It is given. Okay. So here 0 to 20, 20 to 30, 30 to 40, like this it is varying. So as usual question, but there is only one thing is different. What does that mean? The class size is different each time. What is the class size of this? What is class size for this? 20. And then for this, we have class size 10. For this 10 again, for this 10 again, and then for this 10 again, for this 10, 70 above. As they are talking about marks, 70 and above, we can take it as 70 to 100. So it is 30. If you draw a picture using these frequencies, okay, that data, that representation won't be correct. Why? Because the area of the rectangle, what I mean here is that bar of that histogram, the area of the rectangle is proportional to the frequency. Okay, if you are drawing like this, for example, let us draw here. What is it? 0 to 20, 20 to 30. Like we have separate variations. See, if you draw a rectangle here, like of height 7, you will draw, right? So here length of the rectangle is 7. This breadth we can take it as 20. So area of the rectangle how much? It is 140, proportional to the frequency. 7 if you take means what you may take is 20. Look at this next one. 20 to 30 has 10. So 20 to 30 has 10 means somewhat higher. Here this breadth is 10 units and then here also 10. So what is area of this rectangle is 100 units. Now take the proportion of area of rectangle with the frequency. When you take area of rectangle with the frequency, it is 100 by frequency 10. What we got here is 10. So these should be proportional to each other. This ratio should be same all the time. Here it is not same. So we have to make sure that this length is adjusted accordingly to the frequency so that this ratio we may get equal. How we are going to adjust? So for that we should choose the minimum class size. Okay, choose the minimum class size and we are going to convert all the frequencies into new frequencies. Okay, so the new frequency equals, what is that old frequency divided by that class size into minimum class size. So for example, here we'll calculate the new frequencies. Let me do it here. Shall we calculate for this? What is the minimum class size that you can choose from this? 30, 10 or 20? That minimum class size 10 we will choose. Okay, after choosing 10, convert this new frequency. Old frequency is 7 by class size, old class size 20, now new class size 10. Now simplify this. What you may get is 3.5. That is the new frequency. Okay. Also, next one and all you don't need to convert because 10 by 10 into 10 we have to write. 10 by 10 into 10. What will come here? 10 only will come. Here also 10 by 10 into 10. This old class size also 10. Class size 10. Frequency also 10. We simplify. Now here class size varies are same. Frequency divided by class size. See here I am working out. Here let us work out. Old frequency divided by class size into minimum class size. When you simplify this, what you may get? 20 only. It won't change. Where it will change again? Here also no change. Here also no change. Here only it will change because 30. You should convert this 30 for 10. How? See, let me give you another approach if you couldn't understand this means. Usually, for 30 we have 8. Then for 1, how much we have? 8 by 30, yeah. Correct? For 30 we have frequency 8. Then for 1, it's 8 by 30. What is our minimum class size? 10. We have to convert this for 10. So into 10. That is the idea of this formula. When you simplify this, what is the new height you may get? New length. See? If you simplify, what is it? 2.666 or 67. You take it. Okay. Got it? Any doubts on this? Unmute yourself and answer. Okay. Unmute yourself. Good. Now we'll take the ratio between the areas. So instead of here 3.5, what we may choose? So instead of 7, what we may choose here is 3.5 will stop. Okay. So this will become 3.5. Now what is area of this rectangle? 3.5 into 20. How much? It is 70. Correct? Is it or not? So 70, as I told you earlier, the area of the rectangle should be proportional to the frequency. What is frequency? 7, old frequency, whether they are proportional or not. What we may get here? 10. Am I right? For the next one also we got 10. So whether that ratio is proportional or not for all the rectangles. They are equal or not? All the rectangles have equal proportion. And then likewise here also, what you may get? 10 only will get. Length and breadth. Okay. So length is how much? Here 10 into 10, 100. What you may get? Oh, sorry, that is class size. My bad. So class size into that frequency. That is only area of the rectangle. So here 200. 200 by what is the frequency, man? 20. When you simplify, 10 only will get. So that is made equal for all the rectangles. So now we are drawing this histogram using this frequency. We are not going to use the old frequency. New frequency, converted frequency. Then only the area of the rectangles will become proportional to the frequency. Now we will start drawing it. The data starts from 0. We will take 0, 20, 10, 20, 30, 40. Have you noticed one thing? Previous question and all, this number directly even, so we took the same units here. But here, I am not writing the 0 to 20 directly. In between 10 I am inserting because of the units. And then here, 30, 40, 50, 60, 70, 80, and then 90. What could be the scale? Can anyone say? Scale on x-axis. How much we can take? Look at the frequencies. After that we can decide. 5, 10, 15, 20 is the maximum frequency. It won't exist. Or else you can write 1, 2, 3, 4 also. Not a problem. We have a big graph sheet. Okay, now 0 to 20. What is the frequency? Unmute yourself and answer. Come on. What is the frequency? 0 to 10. Sorry, 0 to 20. 7. New frequency only you should take. So 0 to 20, 3.5. Okay, approximately I am drawing. You should draw a graph sheet. Okay, and then 20 to 30. What is our new frequency? 10. And then 30 to 40 also 10, I think. Is it? Ah, yes, 30 to 40 also. Oh, here I wrote 20. Why I wrote 20? It remains same. It won't be 20. See, you apply in this formula. 10 by 10 into 10, that is 10 only. Okay. And then 30 to 40, again 10. 40 to 50 also 10, I think. Oh, sorry, 40 to 50 it is 20. And then 50 to 60 also 20. And then 70 to 100, I am not changing the class size, but frequency alone changing. It is 2.66. This like you may get, right, somewhat below this. Okay. Why? Because then only we'll get the these ratios satisfied. Any doubts in this? This is one such important question. Now look at the exercise. In our exercise, the last question, I mean the 8th question. Now look at the 8th question. What do you observe in that? Yeah, it starts from 1, not a problem. No need of broken line as well. 1 to 2. Class size of first class interval is 1. Second class interval 2 to 3. Class size for that is again 1. Next class interval 3 to 5. What is the class size? 2. Likewise, 5 to 7 again 2. 7 to 10 3. 10 to 15 5. Class size is varying. When class size is varying, what we have to do? Yes. So you guys are going to tell me the new frequency for that. So first, have you finished writing this? Okay, finish writing this. Then only we'll be seeing that question number 8 and 9 of this same type. You people will have to solve yourself. Okay, make it fast.